Hi class, welcome to Lesson 7, Introduction to the Atom. At the end of this lesson, you should be able to identify the subatomic particles of an atom, determine the number of protons, neutrons, and electrons and nuclear charge in a neutral atom, and describe how changes in subatomic particles can create isotopes. In class, we will distinguish between atoms and ions. So hopefully the three major subatomic particles are review for you from middle school. But if not, that's okay. You need to make sure that you know all of this material about the three major subatomic particles, the proton, the neutron, and the electron. The proton is a subatomic particle found in the nucleus. It is a positive charge. So it is a positive 1 charge and a relative mass of 1 AMU. An AMU stands for an atomic mass unit. We say that a proton has a relative mass because the actual mass of a proton is infinitely small. Since the mass of a proton is so small, we're just going to compare it to the other subatomic particles. Now, if you look on your reference table O, you will see the symbols for the major subatomic particles. So a proton can be written with a lowercase p and its charge in the upper right-hand corner. In chemistry, we don't typically write the number 1. So if you see a plus sign, it is understood to be a +1. Now, the nuclide symbol, or the symbol of a proton from the nucleus, looks like this. So we know that the proton number is very important because it determines what's known as the atomic number. When we look at the sample in the upper right-hand corner from the key from our periodic table, notice how the atomic number or proton number is bolded, as is the element symbol, because these two values go hand in hand. So the proton number determines the identity of an element. In the upper left-hand corner over here, you can see that we have a sample that has 3 protons located in its nucleus. So if we look at our periodic table, we are going to look for the element with the bold atomic number 3. So this picture is a picture of lithium. Now, neutrons are also found in the nucleus, but they are not charged. They have no charge, but they have the same mass as a proton. Their mass is 1 AMU. Now, because there's no charge associated with a neutron, notice how one way we can write the symbol is simply with a lowercase n, and there's no charge in the upper right-hand corner because there isn't a charge. You can look at the alternate nuclide symbol for the neutron found on reference table O as well. So in order to find the neutrons in the nucleus, we are going to use this equation that you have to memorize. It's not on your reference table, that the mass number, and you can see from this key that was on your reference table that the mass number correlates with the atomic mass minus the atomic number. We'll get to more on that later. So here you can see that this lithium atom, we again know it's lithium because it has 3 protons, has 4 neutrons. So its mass number, the mass of it, which is these two numbers together, would be 7. Now, notice how the mass number should be a whole number, but our reference table gives a decimal number. The reference table gives the average mass of all the naturally occurring versions of that element. But when we write a mass number, it should be given to us as a whole number. And finally, the electrons are found outside the nucleus. They're found in these regions called orbitals, and they have a charge of -1. They have a very small mass. So in Regents chemistry, we essentially say their mass is negligible or 0. You can say either or. And notice the symbol for the electron is a lowercase e with the charge again in the upper right-hand corner, or we also have the nuclide symbol. Now, the charge of a species is defined as the positive protons minus the negative electrons, but in an atom, the charge is going to be 0. And so what we'll see is in an atom, when the charge is 0, because we have 3 protons and 3 electrons, there won't be any number in this upper right-hand corner. So again, as a review, inside the nucleus, we have a positive charge because we have positive protons and neutral neutrons. And outside the nucleus, we have electrons that are negative. Now, atoms are going to be neutral because they're going to have equal numbers of positive and negative. So here we can see in this atom, it has 6 positive protons in the nucleus. Can you guess what element has 6 protons? Use your reference table. Don't actually guess. So this is a carbon atom, and it has 6 positive protons in the nucleus and 6 negative electrons outside the nucleus. So the total charge of a carbon atom is 0. So by now, you should be able to identify the subatomic particles of an atom, the proton, the neutron, and electron. Make sure you can describe their charge, their mass, and their location. So it's really important that you're going to write down how we can use our periodic table to find out more about the subatomic particles of each and every element. So you should take a minute to write this down. So you might have to pause the video a couple times as we're going to keep on adding to this list. So again, we're going to start with the atomic number. There's a key on your reference table that gives you where the atomic number is. Again, it's the bold number, and that is always equal to the number of protons. The atomic number is really important because it determines the identity of the element. So here, all carbons have 6 protons, or an atomic number of 6. Here you can see the key that shows us the carbon key from the reference table, and we can see the atomic number. Again, the number of protons is indeed 6. Now, the periodic table is actually organized in order of increasing atomic number. So when you're looking for an element, if you know its atomic number, it'll be a little easier for you to find it. So if we want to find the number of protons, we just look up on the periodic table. So here we see beryllium. Beryllium has a bold number 4. So beryllium has an atomic number of 4. Therefore, it has 4 protons in its nucleus. Now, the next number we're going to focus on is actually the average atomic mass. Now, again, that's an average, but it's directly related to the atomic mass. So the atomic mass is the number of protons and the number of neutrons in an element. The atomic mass is always a whole number. It just happens that when we take averages of lots of whole number atomic masses, we get a decimal number. Kind of like the average American family has 2.3 children, but nobody has 0.3 of a brother. Instead, what happens is you take the average of a lot of whole numbers and you get a decimal. We can use a mass number to help us determine the number of neutrons. Since the protons and the neutrons together equal the mass, if we rearrange this equation, we know the number of neutrons is equal to the mass minus the number of protons. So for beryllium-9, we have a mass of 9 minus the atomic number of 4 to give us 5 neutrons. So here, beryllium-9 has 5 neutrons. Now, the next part that we're going to discuss on the periodic table is the electron configuration, or the arrangement of electrons in an atom from closest to the nucleus on the left to furthest from the nucleus on the right. So this shows us how the electrons are arranged, and the outermost electrons, the ones on the right, are called the valence electrons. They're really important because that is where all chemistry occurs. So chemistry is the sharing and transferring of valence electrons to form and make bonds. So in an atom, you can find the total number of electrons by either adding up the numbers in the electron configuration, so 2 and 4 equals 6, or you can simply look at the atomic number, because in all atoms, the number of protons will always equal the number of electrons. So for beryllium-9, what we can see is that it has 4 total electrons, and 2 of its electrons are valence electrons because they're on the right. Same thing with lithium. Lithium actually has 3 total electrons, but it only has 1 valence electron. The last variable that we'll have that could be on a chemical symbol is its possible ion charge. The key on the reference table calls the possible ion charge the selected oxidation state. Now, when a symbol is written and no charge is placed in the upper right-hand corner, its charge is understood to be 0, so we're dealing with a neutral atom. But if a charge is there, then we no longer have a neutral atom, we have an ion. So atoms tend to gain or lose electrons to form ions, which are more stable than the atoms that they came from. So ion charge is determined by taking protons minus electrons. So just write this down so that we can discuss and use this information in class. So by now, you should be able to determine the number of protons, neutrons, and electrons in a neutral atom. Neutral atoms have no overall charge because their protons equal their electrons. But we also need to be able to determine nuclear charge. The nuclear charge is only the charge inside the nucleus. Since in the nucleus there are positive protons and uncharged neutrons, the nuclear charge is always the same as the proton number. So when we look at carbon, we know that because it has the bold 6 as its atomic number, it has 6 protons. So the nuclear charge of a carbon atom is positive 6, even though the overall charge of the entire carbon atom is 0. Let's practice with this boron 11 atom. Now we can see that it is an atom because relative to the symbol, if we take the pointer, see there's no charge here in the upper right-hand corner. So this is an atom, not an ion. We'll deal more with ions in class. For right now, we're just going to look at atoms. So we're going to use our periodic table cell, which is right here, to determine all the parts. This bold number, called the atomic number, tells us that boron's atomic number is 5. Now, the mass number is related to the average atomic mass, but you need to be given the mass number or information to determine the mass number yourself. So this 11 is the mass number. So our mass number is 11. Now remember that the bold number, the atomic number, is the number of protons. So boron 11 has 5 protons. To define the number of electrons, we take mass minus protons. So remember, if you just look at the periodic table cell, and if you place the mass here, our mass is 11 because that's what was given in the symbol. It's going to be 11 minus 5. So there are 6 neutrons in boron 11. The number of electrons is either the sum of the electron configuration, which is 5, or you can just take the number of protons when you're dealing with an atom. Again, we know it's an atom because there's no charge here. We can see that if boron had a charge, based on the periodic table, it would likely be a positive 3. But our symbol has no charge, so the number of electrons is 5. So the charge inside of our nucleus is due to our 5 positive protons and our 6 neutral neutrons. So the charge of the boron 11 nucleus is plus 5. But the entire atom's charge must take into account the positive protons, the neutral neutrons, and the negative electrons. So the charge of the boron 11 atom is 0 or neutral. The last thing we want to look at this lesson are isotopes. Isotopes are elements that have the same atomic number or number of protons, but a different mass due to a different number of neutrons. And when all the matter was created during the Big Bang, it just so happened that elements were born with different masses. So there are elements that have the same protons and they will have the same chemistry, but they have different number of neutrons or different masses. So we can see that we would write their isotope symbol with the mass in the upper left-hand corner and the atomic number in the lower left-hand corner. So carbon has 3 isotopes, carbon-12, carbon-13, and carbon-14. But when we look at the pictures, every single version of carbon has 6 protons. So all carbon isotopes have 6 protons, but they have varying amounts of neutrons which affect their mass. This concludes lesson number 7. Make sure that you've taken good notes. Make sure that you write down any questions you have and bring them to class. Share them and we will discuss them. Complete your homework on Google Classroom and put your reference table and your calculator back in your backpack so you are prepared for class. I will see you soon.